All right, folks, let's look at example number 3 on all of these types of problems related to coming up with a net ionic equation. But just one more time, let me remind you, our goal is not to do a net ionic equation, although that is exactly what we will end up with. Our goal is to think about the solubility of these slightly soluble compounds and how the addition of this acid is going to affect it. So what we're looking at here is solid magnesium oxide. And so once we start adding this nitric acid to it, the first thing that's got to occur is this magnesium oxide is going to begin dissolving into magnesium ions and oxide ions. And so that's reaction number 1. Again, low K value. So the K value of reaction number 1's much less than 1. I don't actually know what it is. We could look it up if it were really important, but I guess I'm just leaving that for you to trust me. Reaction number 2, what we're doing is taking the nitric acid. And just as I did in example number 1 and example number 2, the nitric acid is HNO3. And to remind you, one of my first questions in class to one of you would be, well, is that a strong or a weak acid? And you would all respond, obviously it's strong because it's got 2 more O's than H's. And so knowing that it's strong, we know it's going to ionize completely. And so we can get rid of the nitrate, because one thing we would form would be magnesium nitrate. All nitrates are soluble. We'd cancel out the nitrate, so why not just do it now? So we'll ignore the nitrate. So what the hydrogen ions, being positive, are attracted to are the oxide ions. So we'll end up reacting that hydrogen ion with oxide ions. Now notice the hydrogen has a +1 charge. The oxide has a -2 charge. So aren't we going to need 2 hydrogens to react with this oxide to end up forming water, or HOH, however you would like to write that? And it's got a similar K value. Again, I don't exactly know it off the top of my head, but it's unimportant. But it's got a K value much similar to this one, where this one's on the order of 10 to the +14. This will have a K value similar. Again, I don't know what it is, but it's going to be greater than 1. And so this second reaction will end up driving the overall process to completion. And so what we'll end up doing, canceling out the oxides, and so magnesium oxide is reacting with a pair of hydrogen ions to form magnesium ions and a water, that's going to be, and a water molecule. And so again, by adding the hydrogen ions in the form of this acid to this solid, it causes it to dissolve more and more and more. And if I had solutions and such, I would be showing you some of these things. So I guess some of it you're just taking on blind faith. And so I'll stop there. Yet one last time, the sample problems, you will find those related to these questions. I'm looking right now. You will find those sample problems related to this. Looks like on page on page 18, number 13 through number 17. So if you're looking to sample some of those problems, that'd be a good place to start. Problem number 12 on page 18 is discussing exactly what I was mentioning in example number 2, where the calcium carbonate acid hits it, causes the dissolving reaction of calcium carbonate to occur more and more and more. So much like I was mentioning about the structures in Athens, Greece, like the Parthenon, similar kind of deal occurring. Practice those problems. I'll be producing another video related to titrations in a moment. See ya. Take care.